Hello, we're going to talk about the intersection of a line and a plane. Now, given that we have some plane right here, we'll call it pi, and there's the normal vector right here. We have the normal vector, and then we have two different types of lines, right? We can either have there's two types of lines that can happen. You can either have it parallel to plane. If it's parallel to plane, so then either it'll be in the plane, or it won't intersect it. If it's not parallel to the plane, then the vector that has to cross at some point. So that's the concept that we have to do. So we can find this intersection of the plane as long as the vector isn't parallel to it, or the line isn't parallel to the plane. So there you go. So let's go ahead and look at an example, and it says that this example is example 44. It says the line L with vector equation r is equal to 2I minus j plus 3k and plus lambda times the vector I minus j plus 2k, and the plane pi with the Cartesian equation. So here's the equation of the plane. This is the vector equation to the line. So we got the Cartesian equation of the plane, 2x minus y plus z plus 2 equals 0. Find the coordinates of the point of intersection. So if we look at this this vector, sometimes I like to write this vector out. I could write this vector 2, negative 1, 3 plus the lambda, and then it would be 1 minus 1, 2. It's a little bit easier to see what this works out. And from this I can see my x coordinate in a parametric form would be 2 plus lambda. My y would be negative 1 minus lambda, and then my z would be equal to 3 plus 2 lambda. If you wanted to write it out, you can. You didn't have to, though. I could have just taken all my I know what my x coordinates from looking here. I could have said this is 2 plus lambda, right here. I could have said negative 1 minus lambda right here, and I could have said 3 plus 2 lambda here, and then I could plug those into the equation to find out what my actual scalar is, the perfect scalar that will fit, that makes where this line will cross this plane. So I'll go to my x coordinate for down here is 2 plus lambda, and then I'll have minus z, which is negative 1 minus lambda, and then I have plus z, and z is equal to 3 plus 2 lambda, and then I'll have plus 2 equals 0, right? Just to property this out, I'll have 4 plus 2 lambda plus 1 plus lambda plus 3 plus 2 lambda plus 2 equals 0. Let's go 4, 5, 6, 7, 8, 9, 10. So I have 10 and 2, 3, 4, 5 plus 5 lambda equals 0. And then I can figure out my lambda minus 5. Minus 10 divided by 5 is negative 2. And then I can go ahead and figure out what my x coordinates are. I have them figured out right here. So if I plug negative 2 in here, I get 0 for my x coordinate. And then this would be a negative 1 minus a negative 2 is plus 2, so that's 1. And then plug in a negative 2 here, I get negative 4. Negative 4 plus 3 is negative 1. So there's my point of intersection. A little messy here. Right here, so that's a 0. What that comes out. Here's my point of intersection where this equation, where this vector equation intersects this plane right here. So good. Next concept we're going to talk about is that distance from a point to a plane. Whenever we're talking about the distance to point to a plane, we're always talking about the perpendicular. If the point isn't on the plane, it's always the perpendicular line, because every other point, this is the shortest. We're always talking about the shortest distance to the plane. So the shortest distance to the plane will be the normal line that goes through this point, right? So that's what we're talking about when we're talking about distance from a point to a plane. So to see this in an example, it says we're given a diagram here. We have the equation of a plane. This is plane pi with this equation x plus y plus z equals 2. We have this point, negative 1, 1, negative 1, and the normal vector. Find the vector equation of a line L through the point A and perpendicular to plane. Well, since we have this equation here, I know that my normal vector, right, would be have the coordinates 1, 1, 1, right? because they're the coefficients of this equation of the plane. And then it have to go through this point right here, so I can write my vector equation of the plane. And it has to go through -1, 1, -1, and then I can go through lambda, and then 1, 1, 1. I also could have written this as -I plus j minus k, and then plus some lambda equals I plus j plus k, if you were to write it in that form, right? Find the point of intersection of the p, just like we did before, right? If I go down here and I find the x coordinates to this, well, my x coordinates is going to be -1 plus lambda. My z is going to be 1 plus lambda. I'm sorry, that should be my y. So that's my y, should be 1 plus lambda, and my z is -1 plus lambda. Then I could put them in this equation, and I have -1 plus lambda plus my y coordinate, which is 1 plus lambda. And then my z coordinate is -1 plus lambda, and that's all equal to 2 for this equation right here. And then I can see -1 minus 1, I'll get -1, then I'll have 1 plus 2, I'll get 3 lambda equals 2, and then I can add 1, I'll get 3, I get lambda equal to 1, right? So lambda is equal to 1. Now I can figure out what this point is by these, I have my parametrics over here, right? And then I can write, well, my x coordinate, when I plug -1 in here, is going to be 0. And then when I plug lambda in here, I'll get 2, and then I'll get 0 over here, right? And then the last question says calculate the distance from, so we found out the intersection P right here. We have point A, right? So, which is the point -1, 1, -1, and I want to calculate the distance between them, right? So, what was it? It was -1, 1, -1. And I want to find the distance between those 2 points. So I can say that well, I could say PA, that distance is going to be the square root of -1 minus 0 squared, so which is -1 squared, 1 minus 2, which is plus -1 squared, and -1 minus 0 is another -1 squared, and this is just going to be 1 plus 1 plus 1 plus 1, or my distance right here is just the square root of 3. And so up above, the distance from this plane to this point is always a perpendicular line, and we just found out this point PA is the root 3, is the distance from here to the plane. Sound good, guys? Thanks.